I can see this.
So kindly give me a cue whenever you want to move the slides.
Sure. Thank you so much.
We proceed now.
Yeah. Waste utilization and value addition in bamboo products and technologies. Next slide, please. Since the last 2 decades, we all know about the usual jargons used for bamboo: green gold, green steel, sustainable, carbon sequestering, eco-friendly, free, grass, rural empowerment, tribal empowerment. All these are very much known to us. Now it is high time that we start getting things into practicality, and we don't seem to have much time to waste because China is catching up like wild rage, and we are still stuck with our policy regulations and a lot of issues. Next slide, please. So we'll talk about the negative things first, so that we'll get some vengeance to work a little faster, maybe, and more strength. So you can load the content. China, as we all know, we exports close to 2.5 billion USD in the bamboo sector. India with the second largest bamboo cultivation. I wouldn't I don't think it is right to call we have second largest bamboo cultivation, because we seem to have only the bamboo resource, because probably most of our resources lie with the forests, that is the RFAs. So we could say that bamboo, we have the second largest resource, and we still export close to 150 million USD for the last year's data, which is not even 1,000th of what China does. And we seem to have very poor data management when it comes to the bamboo sector so far, and we are not still very clear on the amount of non-forest bamboo plantation areas, availabilities, etc. Even the National Bamboo Mission website, in the plantation page, shows only a cultivation of 4,810 hectares, which I think is not the real value. There is something wrong there. Whereas China has access. When we say access, it has access to a resource of 7 million hectares of bamboo. And as we all know, the average yield of bamboo is extremely poor in India, about 1/5 of that of China. A very critical area which we need to focus on. And our entrepreneurship in bamboo has been mostly limited to small entrepreneurs and cottage industries, and most of the micro mini industries sector. And we also have lots of implementation delays and a lot of things which we all know already. And we also seem to have a lot of limitations in techno-economic diversity, because once we try to develop technology, we are not able to speed up the commercial viability aspect and the economic viability aspect of this technology.
Shri Vaidyanathan, Vaidesa. Ladies and gentlemen, please be on standby. Looks like Murphy's Law is working with us today. Expect the unexpected. We've lost Shri Vaidyanathan's connection.
Yeah, I'm sorry. I seem to have lost connection. I'm back again. Am I audible?
Yes, sir. You're audible now. Please go ahead. Sir.
Next slide, please, sir. Next slide, please. Again, farmers in India have lots of ambiguous inputs from various quarters. There are a lot of problems which farmers are facing as far as the consistency of data input is concerned. Whereas China has already established very fixed and specific cultivation strategies and methodologies for bamboo sector, as in every other sector. Again, our industry institute farmer interface rarely exists in India because we are not able to coordinate well within all the stakeholders. Whereas in China, it's almost a tradition to cooperate with all the stakeholders starting from the beginning, and their pace of work and pace of actions are very quick. We also have socio-political and socio-psychological parameters which overrule practicality in India, because practically when we go to do some works, there are so many other parameters which seem to come in the way. Whereas China focuses on only the result, time-based results. We have got our policies which come with regulations in India, whereas China works on facilitation. We work on regulations, China works on facilitation. So that the entrepreneurs there are free to think of what next to do, whereas our people have problems only, are free only to think of what might be the next problem that might arise. Anyway, these are all the negative things which we need to consider, realize, appreciate, and then work on, because pinpointing all these may look a little what do you call low energy stuff, but it's high time we realize all these and then go into how to circumvent all these issues and then go on a full scale into what we can do ahead. Next slide, sir. Some of the plantation sector actions which may be able to work out this fixation of farming practices for all agroclimatic zones, just like Dr. Hegde sir was mentioning in his slide. We need to fix the farming practices, and the net yield of bamboo cultivations increasing is a very critical area which we need to work on a very fast pace. And specific data on economics and farming to be delivered to the farmers, so that they have ready access to data in their hand, and development of nano biochemical inputs necessary to improve disease pest resistance, improve yields consistently, release of plantation material specific to agroclimatic zones as discussed earlier. And strategic utilization of financial resources budget by GOI for the bamboo sector for every financial year, because this seems to be very important, because we need to develop the machinery. Technology alone might not be the end of the road. It's as good as the beginning of the road, because it has to be backed up by good machineries and very innovative and practical machineries, which India is very much lacking, and we are almost fully dependent on imports for most of the higher grade machines, which is a very sad part of development of the bamboo sector here. Though we do have a lot of machinery people, there seems to be productivity issues and practicality issues, and working with the entrepreneur rather. See, now the entrepreneur has to work with available machinery, and he cannot. He seems to an entrepreneur doesn't have the time and energy. He doesn't have the facilitation for time and energy to work on discussing innovation in machinery based on his product requirements, market requirements with the machinery supplier. So either ways, we need to focus a lot on machinery, and probably the government could work on the lines of minimum support prices for specific bamboo varieties which are commercially enlisted, and credit lines and crop insurance for the bamboo farming sector may be worked out, and be very important for more farmers getting into more small farmers rather, getting into the bamboo cultivation sector. Next slide, sir. Well, let's look at some of the positive points that we have in hand already. Bamboo, as we all know, can be the real savior, we could say, for tribal empowerment and rural sector growth, and it could generate work in millions, because the chain of work that can be created out of the bamboo sector is enormous, and there seems to be no limit. And bamboo, as we all know, again, is a fast realizing output when compared to timber. Then we can have very high density plantations. We've got lots of experts dealing in high density plantations in India, in most of our ICFRE based institutions and other institutions working in the bamboo sector. And bamboo provides rapid expansion of green cover and the ultimate carbon sink, as we all know. Next data. And in a paper named Bamboonomics, which was published by TriFed under the Ministry of Tribal Affairs, our Honorable Minister had mentioned very clearly that there are 12.6 million hectares of cultivable wasteland in India. At one stroke, if we say that any farmer, any enlisted farmer can cultivate bamboo for free in this cultivable wasteland, at one stroke we will have more land for bamboo cultivation than China. These are all very fast forward steps which we could think of, or the Bamboo Society or the National Bamboo Mission could suggest or remark to the ministry so that they can consider it, because they need a lot of inputs from the various institutions so that things can be fast tracked. And the forest bamboo availability could be released through specific institutions created under the state forest departments. This would release huge resources into the market for immediate consumption until such time as these cultivations, as discussed above, can come to the output stage. Am I audible, sir? There is a message saying there is an audibility issue.
So if you can keep the microphone closer to, that will be better.
Yeah. Is it okay now?
Better, but still, if you can improve it, that will be nice.
Okay.
Yeah, this is good.
Okay. Yeah, so we'll go to the next slide, sir. Yeah, one more click, please. Thank you. See, if we look at the import and export of wood and wood products in India during the last few years, a very good paper has been published by our newly formed NCCF, that is the Network for Certification and Conservation of Forests, headed by Dr. Srivastava Saab and Dr. A.K. Bansal. So if you look at the imports of certain wood and wood products, you can see that the builder joinery frames, wooden furniture for office sector, the imports and the exports have huge trade gaps. And then wooden furniture for bedrooms, it's 65 million USD against 11 million USD. And then you have you have the fiber board and plywood, where it is around 100 plus against 20-30 million USD. And then sheets for plywood, 236 million against 19 million exports. So we are a huge net importer of all these wood and wood panel based products, which is a stark reality which we need to start addressing right away, so that we can cater to the Atmanirbhar Bharat and vocal for local pitched by our Honorable Prime Minister Modi ji. So, with all these data in hand, it is high time to create policies, and bamboo is one of the best materials which can straight away replace many of the imports listed under this. So we are importing close to 65-70,000 crores of net import of materials as against our export in the wood and panel sector. Next slide, sir. If you look at the quantity of wood and wood products imported during the last 4-5 years, particle boards if you can see the last row, particle boards during the last 1 year, the 185,000, 186,000 tons of particle boards that is imported, which I would say it is close to about 6,000 15 daylight hydraulic presses. So we have scope for replacement of all these imports with bamboo-based panels. And bamboos, of course, the last 2 years we do not have much of data, and still we have 2017-18 we have imported about 975 tons of bamboos. Yeah, next slide, sir. So let us look at the waste utilization. As Dr. Hegde was telling that out of 1 kg of tulda, they recovered about 160 grams of sticks for incense sticks purposes, which is just a 16% utilization of bamboo of a raw material, because this is where India is not able to compete with China. It's a simple reason, because more than 80% of our material going into waste. Maybe we may be converting a small part into fuel or something like that, but let us say we are wasting about 2/3 of our bamboo raw material. That is where the waste utilization, waste to wealth opportunities is where India can immediately think of competing with most of our competitors. And there are numerous products of excellent value addition that are missed totally in the fight for survival by existing units. Because as we discussed earlier, we have only time to solve our basic problems, day-to-day problems. We don't have time to think of innovation or coordinating with institutions or farmers and machinery providers. And waste to wealth is the future, as we all know. And smart waste conversions can add a lot of value and would change the scenario of revenues in the bamboo sector. And next click, sir. Yeah, one of the more core areas which we can focus on is the conversion of mixed particulate waste. Because when we say particulate waste, we all think of certain quality of the waste. To
Shri Vaidyanathan ji, sorry to interrupt. You're not audible, sir. No, sir, you're not audible. Your voice is breaking. Since you're presenting from mobile, can you move closer to a tower? While we wait for Shri Vaidyanathan ji, my humble request to all the participants to think on some of these ideas and issues. And I would appreciate if you can write down all these, your thoughts in the chat box so we can consolidate. Yes, the speaker is going to connect again. Kindly be on standby, sir.
Is it okay now?
Yes, sir. Better. Please proceed, sir.
Yeah. So conversion of particulate waste into various different formulations will pave the way for higher value addition and the opportunity to think of so many different products, from nails to dinnerware, exterior facades. Product possibilities are numerous. Next slide, sir. See, we have got these bark waste, powder waste, and this slicing waste, splitting waste. So we have got so many different kinds of waste in bamboo sector. Next slide, sir. One of the few things which we can think of on a mass scale are moldings such as these, from highly compressed panels. We can supply to people who make frames, different kinds of frame, and all such creative materials for interior uses. Next, click, sir. Buttons, shirt buttons, different kinds of buttons are huge possibilities which we can convert out of bamboo based molding powders. Next slide. One of the sector which India has not entered much is the wooden nail sector. So once we convert bamboo waste into ultra fine powders, of course we do have a lot of powdering micropulverizer machines which we can take the mesh size up to talc mesh. We can think of getting into the wooden nail sector. I would like to remind that Lignolock, a company based in Austria, which was taken over by Beck, the Beck Polymer Group. It's now Beck Lignolock. They are the world's largest makers and suppliers of uh, different forms of wooden nails. We can go to their website and see how they try to manufacture and promote these. These are one of the best suited for bamboo molding powders, because bamboo based powder molding powders, because we can mold these into shape and then create mechanisms to make highly compressed compact wooden nails which can be of huge use. One of the areas where these are used is in the wooden pallets, because in India and in most of the other countries, the normal steel nails are used, because of which single-use wood pallets become non-recyclable. It's a major issue worldwide, because when pallets go from third world countries, they are all pneumatically or manually hit and fixed with nails. The legs are fixed with huge steel nails, which make them non-recyclable. So if we shift into wooden nails or bamboo-based nails, the entire value chain of the wooden pallet industry will simply change over, and the entire waste can be used in recycling of those wooden pallets. Next slide, sir. Yeah, this is a picture in which you can see the wooden nail function. The way it is, these are all pneumatically thrust into the wood, and it's used. You can see in the Google and or probably even in YouTube. You will have videos of Lignolog and other similar European manufacturers. Next slide. Yeah, as I was saying, once we convert bamboo waste into ultra fine powders, then we can design and formulate so many different varieties of molding powders based on these. And some of the applications remain as stoneware melamine, where it's ultra high compressed and then created into various designs. And these are all lifetime products made out of bamboo powder, which can be thought of. China has already entered into these in a big way, and it is high time we also think of utilizing these, formulating these molding powders out of bamboo wastes. Next slide, sir. Then the prelam particle boards and plain particle boards. One of the major applications of molding powders can be high lamp sheets. We all know the bakelite high lamp sheets, the world famous bakelite high lamp sheets. So once we convert bamboo molding powders into high lamp sheets, then we can say the rest is history, because high lamp sheets can be used in a wide variety of applications and purposes. They can be formulated into specific grades such as electrical grades, flooring grade, facade grade, roofing grade, and furniture grade also. Any the huge requirement and conversion possibilities for high lamp sheets out of phenolic and melamine based bamboo waste powder related formulated molding powders. Next slide, sir. Then we have the skating boards can be straight away bamboo molding powders can be straight away compressed into molded skateboards, and box beams, then various bent furniture components, and one of the applications of that is non-commercializable bamboo waste can be filler boards for doors. It can be acoustic filler boards, normal filler boards, fire-rated filler boards. The there is no limitations for formulations of all these wastes, and it is high time we need to scale up our technology, efficiency, effectivity, and world-class resin technology and grades of products. Next slide, sir. Yeah, when we talk about building facades and from highlam sheets, you can talk about on the left, you can see two exterior laminate designs. On the interior, you can have ceilings with 3D designs, and we all see in various types of boards, MDF and gypsum boards these days. So all these can be shifted to highly compressed bamboo, where we will have extreme strength, as well as we can reduce the thickness of sheets, leading to the possibility of increasing the productivity, because as we reduce thickness of ceiling from 9 mm to 6 mm, so we get straight 1.5 times productivity increase, and also the availability of resources also increase. Next slide, sir. Another beautiful product which can come out of bamboo molding powders is roof shingles. Now we have all these shingles based, that is a bitumen acrylic based roof shingles in a big way. And some of the European companies like Onduline, etc., have been pushing in roof shingles into the Indian market. And again, roof shingles is also a net import in India, because very small number of companies seem to make roof shingles in India. These are all huge markets where mass markets where bamboo molding powders can do wonders with laminates. And these days we have extremely tough and highly weather resistant lamination possibilities with the introduction of various acrylic lamination materials from Mitsubishi and Rom Germany, etc. Next slide, sir. Again, one of the segments in which bamboo sector can improve is the formaldehyde emissions certified products. Contrary to perceptions, bamboo panel need not be a very costly affair. So we need to develop panels. See, we are always focusing on plywood, particle board, MDF. There are so many other possibilities of bamboo which we have not even had the time and energy to think of, because as we discussed earlier, we do have other survival issues on a daily basis. So it is high time that we develop panels to be placed at the appropriate market and at the appropriate pricing. Next click, sir. Yeah, it's high time we use advanced resin technologies, additives, intermediates, treatments, which can be incorporated in order to make, today the world is talking about formaldehyde emission, the problem with leaching chemicals and all those products. So first world countries have already started implementing very stringent formaldehyde emissions, even in exterior grade products like container flooring, because containers are enclosed surfaces. So even in exterior grade materials, many advanced countries have started implementing highly stringent emission norms, especially for formaldehyde, like the E0. We are all very much aware of the popular term E0 plywood, E0 MDF, etc. And CARB phase 2. CARB is nothing but California Air Resources Board, which is a Californian state authority which takes care of the interior, that is the interior air toxicity control measures. It's called the CARB phase 2 emission norms. And the Japanese standards F4 star and no added formaldehyde rating. in interior grade products and panels. So, first world countries can be a major market if we can think of producing panels based on these certifications. And India does have all the technology for all of these developments. And our mother institute, IPRITI, in the wood and panel sector, is doing a wonderful job these days. These days for the advancement of resin technologies. Next click, sir. I hope I'm audible enough. Yeah, technology and scale are the only ways for progress. And we need to increase the bamboo products portfolio, and also in order to progress the industry sector. So the right technology and the right scale is very much important in future uh, in order to stay competitive. Next slide, sir. Yeah, I believe that molding powders made out of bamboo wastes are the future of bamboo utilization. And non-commercial bamboo species can become very high value raw material additions. And especially since, for molding powders within a single species, whether it is Bambusa tulla or Bambusa or strictus or Balcoa, anything under the same grass can go into high pressure moldings with effortless ease. There can be mixed bamboo species, and once we convert these raw materials into ultra fine molding powders, then probably there is no limit at all. And again, as I mentioned, we have multiple formulation advantages specifically designed for applications. Next click, sir. Yeah, the time-tested phenolic melamine and melamine urea formulations in molding powders create endless formulation and design capabilities in out of bamboo wastes. And if we look at the cottage industry sector, we can go for molding cooperatives and communities of molding, where next click, sir, where every single household in the rural sector can do various kinds of job works on piece rate basis, or entrepreneurs can support them with regular orders, and can interact and coordinate with them for timely advancements of their molding capabilities. And once we get into the molding segment, once bamboo wastes get into the molding segment, then there are endless opportunities for job creation, supply chain creation, and huge opportunities for the rural and tribal sector. And high lam like panels, with wear layers, as I had mentioned, we've got lots of opportunities by utilizing wear layers created by many of the chemical corporations around the world for exterior grade materials. So since we talk about WPC, we don't need plastic at all, in fact, because we can have these phenolic and melamine based molding powders with appropriate surface wear layers and laminations in decking, uses in our exclusive areas such as tech parks, airports, and government administrative buildings. Bamboo can replace everything, everywhere, every panel, everywhere. I would like to make this very audacious statement that even if it is a bamboo waste, probably we could say the forest wastes are just grass waste for us. Even if it is bamboo waste, bamboo panels, bamboo based panels can replace every panel everywhere. And there are numerous applications, as we discussed, ranging from floorings, wall panels, ceilings, roofings, and facade, frames, door skins, and including sandwich ready to assemble housing segment. And this can change the way coastal houses are made, because these days we have lots of problems with cement, and the quarry dust doesn't have the right adhesion, and salt in the air attacks them, and we've got issues in corrosion of the TMT bars, and 5 to 7 years down the line, cracks coming up, and climate change issues, a lot of things. So sandwich RTA housing with these molded panels or skin panels, can be a big way to introduce bamboo into the housing sector. Next slide, sir. Yeah, future looks definitely green and golden, and bamboo is the most promising material in India. Just as we had mentioned, as our Prime Minister Dr. Modi ji's Atmanirbhar Bharat and Vocal for Local vision, this can be the most potent material for replacing most of the panel imports. And this is the most appropriate time and period to act on these visionary aspects of our Honorable PM. And it can fill the gaps in quality particle boards, panel requirements, which are currently met by huge imports, as can be seen by the import data. And bamboo can replace wood in the panel industry to a large extent and reduce unnecessary wood use, thereby contributing towards increased timber availability for other sectors of the panel industry. And our time to act is right now, and there is no time to waste further. Jai Hind. Thank you for giving this opportunity for discussing bamboo wastes. And thank you all. Good luck.
Thank you very much, Vaidyanathan ji. It was a wonderful presentation. It reinforces our core belief that no waste is waste. It's today waste is gold for all of us.
True, sir.
We will move on to our Q&A session. The first question will be from my side, sir.
Yes, sir.
Now, when you look at 3D printing, especially when you talked about RTA, today houses are being printed, no more built, right?
Yes.
In this case, can we use this composite material as an input for 3D printing, especially for this technology called CLIP? It is used in, where you can actually remotely print a house. Is it possible to use this?
Yes, very much, sir. The 3D printing, of course, requires injection moldable plastics.
Correct.
Whereby we cannot do the thermoset. You cannot use the thermoset synthetics in 3D printing. So of course, with there are a lot of printable formulations in thermoplastics, and even high-end thermoplastics can like Ultem. We all know about the polyethyramide, which was a General Electric patent. It's called Ultem, the ultimate engineering material. These are all 3D printed in the space and aerospace segments. And of course, with the right formulations, ultrafine bamboo powders can be good, excellent fillers for 3D printable designs.
Okay, thank you very much.
Thank you, sir.
I have some question. I'm Giriraj from Maharashtra. Can I ask?
Please,
sure, sir.
Go ahead.
Go ahead.
Yeah, first appreciation for a very good presentation. Your
Thank you,
central theme was bamboo. I'm CEO Maharashtra Bamboo Promotion Foundation.
Right, sir.
This central was on bamboo molding powders from bamboo waste. That is the central theme around which you have taken.
Yeah.
You said it is good for communities and all that, but what would be the scale? Because is there any technology available in India, or we have to import? And number two, what would be the scale of investment?
So normal moldings do not require much of investment. As we see, for example, we have the melamine dinnerware molding in Faridabad. Faridabad is a main area, just like Yamunanagar for plywood. Faridabad is a major center for small scale molding. So they do all these cups and saucers, bowls. Some people go on doing bowls, some people go on doing saucers, some people go on molding cups. So they have developed a huge, Faridabad is a place where we can visit and probably interact with the molders to understand the concept of molding communities, because there are thousands and thousands of people in small spaces under the staircase, behind sheds, wherever space is available. They put one or two molding units, small molding units with 2 or 3 dies, and then they keep pressing in huge quantities. So all these, probably we could say Faridabad is the molding cluster for melamine molding in India. So these kinds of clusters is what I meant by probably communities, mentioning the term communities. And the technology is readily available in India. And
wonderful. I mean, I think from what you say, we need to do only one or some trials and see.
Yeah. It's very much, sir. In fact, I'd like to share that my dad, Mr. P.V. Hariharan, is a master molder, and he used to mold bamboo-based dinnerware way back in 1980s, 70s, and 80s in a small way, along with other melamine moldings. So in fact, molding powder formulation is not really a big thing, and India has achieved a lot of expertise in melamine and phenolic molding powders.
Okay. From what you say, it's not going to be big investment.
It's not going to be a big investment, sir.
I mean, is it? I don't want to go into the details.
Yeah.
Anyway, I'll talk to you separately.
Yeah. No problem, sir. No problem.
So, Giriraj sir, definitely we will take this offline to see how we can run a pilot. Now we will move on to questions from the audience. Ladies and gentlemen, if you have any questions, please raise your hand. I can see one question from a former chairman, Dr. Sundar Naik ji. Please go ahead, sir.
Sundar sir, namaste. How are you?
Sundar Naik sir, I think he's unable to hear. So,
okay.
Next question, please, from the audience. Yes, sir. Dr. Ken Murthy, sir, please go ahead.
Vaidyanathan ji, very impressive presentation. Because
Thank you, sir.
That the wastage proportion is very high in bamboo when very ordinary products like these agarbatti sticks are made. So your output of agarbatti stick is some 25-30%, even less, and your wastage is something like the order of 80%. We are little worried that this wastage could create huge problems.
Yeah.
Now, based on your talk, I understand that first we have to crush and convert everything into very fine powder of some nice grade.
Yeah.
Use it. Is that right?
Right.
So which can mean that even branches can also be used?
Exactly, sir. In fact, if we go to discussion on that scale, any agrobiomass can be see molding exclusively depends on the fineness of the powders, because compression molding in molding powders depends on hot melt flow. We call it the melt flow index. So if we manipulate the melt flow index, fillers doesn't matter in molding. Fillers rarely matter, except for specific applications like conductivity and thermal insulation, all those things. But normal moldings, any material can be a good raw material if formulated appropriately.
Okay. In continuation of this, my next question is, now in bamboo, the transportation is very high cost because it's hollow bamboo, and then transporting brushwood and all that becomes very expensive, and it is economically unviable.
Yeah.
Is there any way that we can convert this material at the site itself, kind of chipping something, so that?
Exactly. You raised a very critical point, sir. A very critical point. Bamboo has to be. See, we all are aware of this coir baling.
Yeah, coir baling.
So bamboo waste utilization can be done only if we do a baling kind of activity with the chip wastes.
Okay.
So if we bale it, we can convert them into square blocks and then pack them and send it in huge quantities.
Okay. No, my question is, can it be done at the site where the bamboo?
Yes. Baling has to be at the site, sir. Baling has to be at the site of sourcing.
Okay. My last question is, I understand that melamine usage has implications and in terms of health, basically. So just, I don't know, it's my kind of a very random kind of information. So melamine is going down in kind of supply, and also the health has, that's what I understand. I don't know, I may be wrong also.
Yeah. Sir, actually, it is a very nice question. Very, very beautiful question. In fact, see, we all know that. We all know that we are using PVC and polyurethane.
Okay.
Polyurethane comes from one of the deadliest raw materials, isocyanates.
Oh God.
But at the end of processing, it becomes zero in emission, or say scientifically zero, practically zero. So what happens is the usage of chemicals, that is usage of synthetic raw materials, is a fine art of the molder. So that is how this melamine moldings came into prominence, where we even have food grade certified melamine moldings. Even in first world countries like US and Germany, they continue to use dinnerware made out of melamine. And at the end of processing, it becomes zero emitting and zero leaching. And again, it depends on the final processed material.
Okay, okay. So not really big hazard for the health.
No, if it is not a big hazard if processed appropriately.
Okay. Thank you very much. Very useful.
Thank you. Any more questions from the audience? Okay. I have a question, Vaidyanathan ji. Could you talk a little bit about formaldehyde, the restrictions?
Yeah. Sorry, you asked me to speak on those?
Yes, NAF.
Yeah. See,
that is
when it
becoming a
comes
primary
to
requirement now.
yeah, true.
Yes.
Yeah. Thank you for raising this point, of course. So, see, in wood and lignocellulosic panel-based composites worldwide, starting the beginning of, in fact, from the end of 90s, second half of 90s, this problem has been started to be raised, and by the end of early 2000s, especially the state of California was among the first regions, demographic regions, who started to raise concerns about the formaldehyde that is emitted during the operative life of wood and lignocellulosic based panels, 99% of which use formaldehyde based adhesives. Because during the process of hydrolysis, that is moisture attack and different weathering environment, temperature plus moisture plus UV, the residual moisture content in these panels will start creating hydrolytic pressure, that is chemical hydrolysis, into the even the cured resins. It is mostly seen in amino resins, that is urea and melamine formaldehydes, which are used mostly. That is 85% of our industry relies on urea and urea melamine formaldehyde resins. So these resins have been seen to undergo very fast hydrolysis, and formaldehyde has been found to be released in a good volume and consistent basis. We
Sorry.
We lost the button.
Shri Vaidyanathan ji.
Hello.
Yes, sir. Yes, sir. Please go ahead. I think.
Yeah. Okay. So, so this hydrolysis generates formaldehyde again from the pressed panels, processed panels, and then formaldehyde is emitted on a continuous basis. So, and we all know that 90% of our time we spend indoors. So, formaldehyde is one of the major indoor air toxicity chemicals, which has been found to create a lot of issues, mainly asthma and this issues related to women due to continuous harmful emissions and our inhaling of these. Because normally a human being inhales about 3,600 gallons of air per day, and even if you have 0.5 parts per million formaldehyde, that's a good volume of air that we inhale and for our oxygen requirements. So formaldehyde emission became a huge indoor air toxicity control measure concern, and California Air Resources Board started stringency in limiting the emissions of formaldehyde during their operative life, installed operative life, and followed by EPA, that is the US Environment Protection Agency, Japanese industrial standards, British standards. Everyone started simultaneously acting on these concerns. And then the world formaldehyde emission standards started to be developed. And there was phase one of CARB standards. CARB is California. It's actually ARB. So along with California, we call it as CARB, California Air Resources Board. And they're in charge of looking at the air pollution in and around California state. So they started implementing the phase one emissions, which limited formaldehyde to some extent. And then they introduced the phase two emissions somewhere in 2009-10, where it was brought down to scientifically zero. That is less than 0.05 parts per million per cubic meter of air. So this creates the necessity to make synthetic resins, which have very low or ultra low formaldehyde emissions during their operative life. And every material that absorbs these resins during curing always has residual resins, and then as moisture attacks their surfaces and interior parts, inner parts of the inner areas of the panel, due to various weather conditions such as heat and ultraviolet impact, even indirect ultraviolet impact can have a weathering effect. So formaldehyde starts getting emitted, and it is a continuous process in every panel. So that is how the formaldehyde emissions got developed, and now I think we are going to have national safe boards standards. It is in the pipeline, and I think a panel has been made and a draft has been made with the initiative of some of our wood-based industry corporates like Century and Green. A panel has been made, and India is also going in for safe board standards for these kinds of panels.
Okay, thank you, sir. Thank you very much for the detailed explanation.
Yes.
I'm sure